networking. So by default, all these pods, these apps are isolated, and you need to define how they should be accessible from the outside. And again, this is a really minimal example. You can specify a lot of details here, and there are also different types of services that we can use. And here I'm using a very simple one that's called the load balancer. And it doesn't do very much except it receives the request and it balances the load. In this case, we have 2 instances of the app, remember? And it will make sure that the load is balanced between those 2. And we tell it should serve this app, My Shiny. That's the same we used before. It should listen on this port, 80, so that's the normal web port. But when it talks to My Shiny, it should do so on the port 3838, because that is what My Shiny listens to. But for the end user, it will look like it's running on port 80. And once we apply that with a simple command, the service is created and everything works, and we can actually view that. So that's the basic process. We have built an app, we have deployed it, and configured networking. That's absolutely fantastic. However, this is a little bit simplistic, so in many production cases we want a little bit more structure to this. So for instance, this is from a security perspective pretty open. The load balancer doesn't do very much security analytics. It will just pass the thing around, and if we want login functionality, that sort of thing, we won't get any help from the load balancer. We would need to handle that in the application. So what we would do in most cases is that we would put something in front of our application. So we have our Shiny app up to the far right, and we put something secure in front of that. We call it a proxy, so it will act on behalf of the app. So the user with his or her browser will believe that they are interacting directly with our app, but instead they're interacting with the proxy, but then the proxy passes on the request to the app. And this gives some benefits immediately. First of all, this is much more secure because our app written in Shiny, etc., it's not foolproof. There are probably ways we can crash that app and hack it and that sort of thing. But these proxies, they are designed to be the front end to the application out to the internet. So they're designed to be really, really secure. They are well tested and kind of battle proven. So just by putting something in the front there means we can avoid some things with like denial of service attacks and those kind of things that we would otherwise be vulnerable for. It also allows us to use HTTPS. We get this from the cloud platform, at least on IBM Cloud. When you enable this technology that we call ingress in Kubernetes lingo, you get by default an IBM issued certificate that gives you the green padlock in the browser, and you can use encrypted traffic. So that's a good thing. It also means that we can tie this into another service or into a service on IBM Cloud that's called App ID. And App ID implements a user registry where we can specify these are the users that are allowed to use this application. And in that case, the proxy run by Ingress can check with App ID, okay, this user that is now arriving, is that person logged in, yes or no? And if not, then it can ask App ID to show a nice login form, and it can also provide a password reset, that sort of thing. So we get the whole kind of user management thing by using the Ingress together with App ID. And that is fairly straightforward. I won't show you how to set that up, but in my example files on GitHub, I have a working example of that. So if you're interested, you can check that out. And I have also links to the documentation that describes in detail how to do this on IBM Cloud. This also, another point I want to make here is that previously we had just the Shiny app, and it's very seldom that we deploy a production system that is just one Shiny app. It's usually a set of web components. So it can be one Shiny app, maybe one static web page running WordPress or something like that, maybe something written in Node.js, and these 3 or 4 or 5 together make out the system, the application that we want to expose to the end users. That's really, really common scenario. So in this case, I illustrated that by adding two web app A and B that are also important. And in this case, we can tell Ingress that these three apps are all together in the same application. So if the user is signed in, he or she is allowed to use them all. So there will be a single sign-on, as we usually say it, so that if person goes into the Shiny app, signs in, then that person can go to web app A and B without signing in again. So it sounds really simple, but when this doesn't work, the users get really, really annoyed, and that happens from time to time when we haven't implemented this. So this is more like how we would do it in our real cases in production, but it's just it's a very small difference basically from what we showed on the previous slide. So now we have deployed the Shiny app basically. Well, I haven't showed you, but you have to trust me, it works, and you can try later if I'm correct, if my example files work. So we have gone through this process, and I just written quickly the major commands that you need to do this. So you use docker build and docker run to make it run as a Docker container and to test it locally. You push it to a registry with docker push. When you apply the deployment file and the service file, you use something called kubectl apply. That's just a command to Kubernetes. I don't want to go into the detail, but basically you just specify that and the file name, and it will do everything. So it's really straightforward once you've written these files. And as you saw, the files are not that complex. I want to transition now from deploying a Shiny app into deploying an API, because that's something also that we deploy. We write an API that responds to requests not from users with web browsers, but from other systems, other components, other APIs even. So the question is how is the process compared to that? So this is the Shiny app process, and this is how to deploy an API. So we changed over here, right? So it's the exact same procedure. We will develop it, we will make it run as a Docker container, etc., etc. There's no difference basically. But on this level, there is no difference. But there's a little bit difference in this box as well. We won't use Shiny to build our APIs. Besides, I should mention that I'm talking a lot about Shiny here, but those things apply to any sort of visualization that we do in R. We can do things with Flex dashboard or other things as well, so it just applies. But Shiny is really popular and really cool. So, but with when we build APIs that should serve web apps, other components, etc., etc., the normal thing, I would say, the common thing that I've come across is to use a R package called Plumber. Who has used Plumber or tested anything? Just a few, okay. And that's a really neat package to create APIs. That's what it's there for. And we will have two steps here. The first is to actually build a model. In this case, we're going to build, this is a toy example. So we're going to build a linear regression model that can predict the price of a diamond given its carat, which I believe corresponds to its weight. So, and this relationship is not at all linear, by the way, if anyone was thinking about that. But we will do it anyway, just because we can, right? So it's a toy example. Actually, if you take the log of the price and the carat, it's pretty linear. So you could try that if you want. As you see here, there's no sign here that we are working with an API of any kind. It's just a standard R file. We will load the libraries, first to get the data set, then to get the right _RDS function. We will require the data frame with data, and then we'll do the modeling with LM. Again, don't worry if you don't follow the details. And then we'll just write the model as a file on our local system. And we need to run that once. Then we have built the model. It exists in our directory as a file, lmmodel.rds. That's the first step, building the model. But then, in order to get some scoring functionality here, we need to provide the API, right? So that's the next step. So we will build an API. And this is the R file that will do that. We need to do two things. We need to read the model, because this is going to run in a different R process, so it doesn't have the model. It needs to read it from the disk. And then we provide a function. This looks a little bit messy, don't worry with the details, but basically it will take the carat as a parameter, and it will run predict using the model with the data that comes from the parameter. So it will just take the value that is sent in, run predict on the model, and return the result as a list. And the only funny business here, except that this is a messy way of writing the function, is we have a little bit of comments here that give away that something special is going on here. And this is what we use to instruct Plumber that this should be an API endpoint. So we say at get, this means we want to use the HTTP get function for this. You can also use post, delete, put, etc. those HTTP verbs. In this case we use get, and we specify the endpoint /score-lm. So when we do get with /score-lm, it should run this function. And we can specify also the parameter and give a little bit of documentation. You can actually generate API documentation out from this file as well if you type in good things. So that saves some time.